Okay, so I had to just write this thing of the second difference, first difference, and the original term right down there. Okay, so as I've said, for the 2a, it's equals to the first term of the second difference, okay, which is our 4, right? And then for 3a plus b, it's equals to the first term of the first difference, okay? And then the a plus b plus c equals to the first term of the original sequence that we've actually been given, okay? So the 2a right here equals to 4, which is the first term of our second difference, which is just constant for all of them, okay? So it's equals to 4. So to make a the subject of the formula, we need to divide both sides by what? By 2. This one and this one will automatically cancel out, and then a is going to remain equals, and then a in here goes once, and then in here it goes twice, okay? So meaning that our a equals to 2. So now that we have our a, we're going to use this fact to find our b. Our b right here, we're going to use this equation right here, okay? So the 3a plus b equals to 3, which is the first term of the first difference of our quadratic sequence or pattern, okay? So when we see a, we substitute the a that we've actually calculated right here, okay? So it's going to be 3 where you see a, which is here, you put your 2 plus b equals to 3. So 3 times 2 equals to 6 plus b, which is equals to 3, and then b equals to 3, this one minus 6. When the positive 6 goes the other side, the sign automatically changes into the opposite sign of the actual sign of C, right? So this side it was positive. So when it goes that side, it's going to be what? A negative 6, right? So it's going to be 3 minus 6, which is equals to what? Minus 3. So now we have our A and B. We actually have to calculate our C. So our C, we're going to use this formula right here of A plus B plus C. It's equals to the first term of the original pattern, okay? So our A is what? It's 2, as we've calculated it over here. And then substitute your 2. Our B, it's what? Minus 3. So it's plus minus 3 plus C equals to minus 9. Okay, so 2, then the positive times a negative, it's a negative always. And the positive times a negative, or a negative times a positive, always negative, okay? So it's going to be minus 3 plus C equals to minus 9. So this and this, 2 minus 3, it's equals to minus 1 plus C equals to the minus 9. So now we are going to, when we're going to take like the one the other side, it's the 1, like the sign of the minus 1, it's going to change into a positive. So it's going to be C equals to 9 minus 9 plus 1, which is minus 8. Therefore, our equation, before you actually do the actual formula, you need to write down the standard one first, which is Tn is equals to an squared plus bn plus c for a quadratic one, for a quadratic pattern or sequence. So now, after writing this one, we substitute our a, b, and c. Our a, it's what? It's 2. So where you see a, you're going to put 2, which is going to be 2n squared. Our b, it's minus 3. Because it's a minus 3, this sign over here is going to change into a minus 3, right? It's going to be a minus 3 and minus 8, which is our C. So this answers our question, our second question. Let's move on to the third one. So our third question is to actually find the new pattern of which is going to be Pn again by adding, okay, which is actually formed by adding 3 to each term in the given quadratic pattern. Meaning we are actually going to add 3 to the actual terms of the original pattern that we're actually given, which is this one, right? So this thing automatically just affects the constant value of our our thing, our pattern. You don't actually have to actually do the calculations and everything. I think this is actually 1 mark as well. So you just take your actual pattern, which is Tn squared minus 3n minus 8. Since we are adding 3, then you just say plus 3 at the end of at the end of the pattern, just say plus 3, which will automatically affect the constant value, which is what? The minus 8. You know, a constant value, it's a value that doesn't actually have a variable or something before it. It's just by itself, okay? So it's gonna affect minus 8. So our formula, our new formula Pn equals to 2n squared minus 3n minus 6. Oh, we can just double check it for you guys. I just did like the two sides for you guys so that the other side, which is this one, actually it's kind of like more clear for you guys to actually understand. Okay, so let's do this. We have our original pattern, which is this one, minus 9 minus 6 1 12 and 27. So this is the original pattern. So the new pattern is formed by adding 3, right, according to the instruction, 3 to each term, like in the given quadratic sequence. Okay, so when we have like our minus 9 right here and add 3 to it, we're gonna have a minus 6. When we add 3 to the minus 6, we're gonna have minus 3. When we add 3 to 1, we're gonna have a 4. When we add 3 to the 12, we're gonna have 15. When we add 3 to the 27, we're gonna have a 30. Okay, so this right here, it's our new pattern, for the Pn equation. Okay, so meaning we are gonna work with this pattern for this question right here. This one, we scrub it off. Okay, so now let's do our first difference using this pattern, right? So minus 3 minus 6, we have a 3, right? So a 4 minus 3, we have a 7. A 15 minus 4, we have an 11. A 30 minus a 15, we have a what? A 15. Okay, so 7 minus 3, it's 4. 11 minus 7, it's a what? It's a 4. A 15 minus 11, it's a what? It's a 4. So you know, I can when we are working with a quadratic pattern, we need to have our first difference right here, our first difference again, and second difference, and original term. Okay, this parts are actually kind of like useful for this, for our 2a, our 3a plus b, our a plus b and plus c. So we start with our 2a. Our 2a is equals to what? The first term of the what? Of the second difference, which is a what? A 4. So it's going to be 2a equals to what? A 4. And 2a divided by 2 to make a the subject of the formula. This side, it's equals to what? 4 divided by 2, because what you do on the left hand side, you also do it on the right hand side, right? So to make a the subject of the formula, 2 and 2 will cancel out, and then a remains this side, and then 2 goes into itself 1 time, and then into 4 2 times. Okay, so we have a equals to what? 2. So now that we have our a, we're going to take this and use it for our next step, which is what? For the 3a plus b equals to what? A 3. 3a plus b equals to the first term of the first difference of the quadratic sequence, which is this one, which is a 3, right? So it's going to be 3a plus b equals to 3, this one. So now that we have our a, we substitute our a as well. Okay, so it's going to be 3, where you see a, you put a what? Your 2 that we have calculated. A 2 plus b equals to 3. So 3 times 2, it's a 6, plus b equals to 3. So b equals to what? 3 minus 6. When you take the 6 the other side, the sign changes from to a negative, from a positive to a negative, because it went the other sign of the equal sign. So 3 minus 6 equals to minus 3. So now that we have our A right here, our A and B, we go to our C. So we use the original term, the first term of the original term, it's equals to this, okay? Meaning A plus B plus C equals to minus 6, which is the first term of the what? Original term. It changed, okay? Because we added 3 to the original pattern. Okay, now it's a minus 6, not a minus 9. So we have our A, which is a 2, our B, which is a plus minus 3, close bracket, plus C equals to minus 6. So 2 minus 3, because a positive times a negative, it's a negative. A negative times a positive is always a negative, vice versa. Either way, it's negative. But a positive and a positive, it's positive. And a negative and a negative, it's still a positive. Okay? So we have a minus 3 plus C equals to minus 6. Okay? So 2 minus 3 equals to what? Minus 1. Plus C equals to minus 6. C, so to make C the subject of the formula this side, we're going to take this minus 1 the other side. But when this minus 1 goes the other side, the sign is going to change from a negative to a positive. Okay? So it's going to be C equals to minus 6, which is this one over here, plus the 1. So it's going to be C equals to minus 5. So therefore, before you write your actual pattern of Pn, here it's supposed to be Pn, because now we are working with P, not Tn. It changed, okay? So Pn is equals to An squared plus Bn plus C. So our A, it's what? You substitute your A, Tn squared. Our B right here, it's substitute of minus 3 and minus 5. You see this and this, where is it? When I said minus 6, it has to be a minus 5 right here, not a 6, okay? 5, you see? So this is a shorter route rather than this one. So when they are telling you they are adding a term or subtracting a term from your actual sequence or whatever and all those things, that thing only affects the constant value of your original pattern. So it's either going to subtract or add on your pattern. Okay, so in this case, we were only adding 3 because it said they were actually adding a 3 to each and every term of the sequence. They were not subtracting, but if they were subtracting, we were going to say minus 3. You see? So, yeah. So, the last question is over here. It says, which term of the sequence found in Q3, which is this one, the latest one, this one of Pn, right? Which is question 3.3, has a value of what? Of 400. So in this case, we are looking for n. We have Tn. In this case, it's Pn, right? Because it's the new formula from, we actually extracted from the Tn one. So this one is Pn. It can be Pn or whatever you want and everything. So in this case, we are looking for the n. Using what? Using this formula right here. We are looking for n. We have which side? We have this side, all of it. So our 400 is going to be equal, it's going to be this side, and then we calculate our n, actual n. So let's get into it. So now we take our 400 and substitute at this side, equals to the 2n squared minus 3n minus 5. Minus 5, right? So we take this 400 and take it the other side, right? So this side it was a positive 400. So when it goes the other side, it's going to change. The sign is going to change from a what? A positive to a negative, okay? So we're going to have 2n squared minus 3n minus 5 minus 400. Okay, so those two are like terms, so we add or minus together, we add them together. Okay, so it's going to be 2n squared minus 3n, but since it's a negative, so it's going to be minus 405. Okay, so here, yeah, I don't know, yeah, okay, so right here, so this part, it's another part of mathematics, but it's a part where you actually have to factorize this. Okay, so I factorized this into this. Okay, so we factorize this part over there into this. Oh, you can also use a quadratic formula. It's there. If factorization is kind of like difficult, you can use a quadratic formula equation. Yeah, I'll just add some equations that are quite useful when it comes to this, mostly in a quadratic sequence. That's why you can substitute your quadratic equation if you have problems with factorization. But I would advise you to, familiarize yourself with factorization. Okay, so I factorized it into this. Okay, so this was supposed to be like this 2 and so I just wrote this step down just for safety purposes so that people can understand here. So for this part, is that 2n plus 27 equals to what? 0, or n minus 15 equals to 0, which is this one. So for 2n equals to 27, I leave the 2n the side and the 27 goes the other side and causing the sign to change. But note that our n can never be a negative, so automatically this one is going to be scrapped out. But I just continued with it for safety purposes so that you understand. Or the n equals to 15. This 15 went the other side. So the sign automatically changes from a negative to a positive 15, which makes sense. Because we can never have a position whereby the position is position minus 20, position minus 27 over, like, nope. You understand? So this one is the only position that made sense, okay? But anyway, so we use this side to make the n subject of the formula. We divided both sides by what? By 2. Right. So the 2 and the 2 this side canceled each other. And then this one, 27 over 2, basically, I think it's 13.5 and everything, but I just left it as a fraction because either way, our n can never equal to minus 13.5, okay? The n has to always be a positive, always. So our n in this case is what? N is close to 15. This right here is the final answer. When you substitute this n into that equation, you will automatically get a 400. You can do that on your calculator. When you substitute your n, where you see an n right here, not the original one there, equation of 3.3 question. So when you substitute your n right here, you must get a 400. We can test that ourselves right here. Let's do it. Let me just... Okay, so we have 2 into what? Our n is 15 squared minus 3 into 15 minus a 5. See, it's a 400. So yes.